Well, ladies and gentlemen, hello again. Welcome to another Reflected Reality Simulations video. My name is Graham. We're in X-Plane 10 at Sofia Airport in Bulgaria, and we're going to be flying over towards Sarajevo. We're going to be flying the Tupolev Tu-154 from Felis. I've had this aircraft for a couple of months. It's a really enjoyable and a really challenging aircraft to operate. It very much reminds me of the Project Tupolev models for Flight Sim 2004 and Flight Sim 10. They were freeware models and they're very detailed, almost groundbreaking when they were released in the level of systems detail you have on a freeware aircraft. This aircraft very much reminds me of that. But I was very surprised to see there's very little YouTube content for this aircraft, and I wonder if it's because it's perceived as being quite a difficult aircraft to get into. Certainly with the Project Tupolev aircraft, the fact the cockpits were all Russian language did make it a little bit harder for English speakers to get started with aircraft, but thankfully this model it's got an English cockpit option, which is very useful. So what we'll do is we'll go through a cold and dark setup, taxi the aircraft out, depart off towards Sarajevo, and then in another video we'll look at the arrival into Sarajevo. The aircraft is very complicated, it's got a lot of detailed systems on it, so rather than focus on why we're doing things with the systems, we'll go through just the standard processes in this video, and then at a later date I'll do some detailed videos on things like the compass system, the gyros, the electrical system, and the autonomous navigation system. But this video will use the Bendix King KLN 90 GPS that's available as a free add-on for this aircraft. First things first though, we need to set the payload on the aircraft. It comes with this handy load sheet here. First thing to note is the Tupolev's got a minimum fuel load of 12.75 tons. You can't load any less than that safely. So we only need 10 tons for this trip. We're going to use 500 for the 5,000 for the flight, diversion fuel 4 tons. If we had no customers on board, the CG would be beyond the aft limits. There are special rules to allow you to fly with an Aft CG, but to keep things simple, we'll put a customer load on there and we'll put some payload in the front. So with that, we've got the fuel on, the customers are on board, are loading. Let's set the aircraft up. So although the external power cart is plugged in, it's not on the aircraft at the moment. We've got to turn the batteries on first. These are the 4 battery switches. 1, 2, 3, 4. And then we'll switch the gauge here to look at the external power. It's important to note none of these switches here, none of these knobs do anything with the power configuration on the aircraft. They just control what's displayed on the gauges. So anything you see me doing with this, you probably don't need to worry about it if you're not that interested. So we've got good frequency, good voltage from the external power. Push the button. External power comes to life, and I'll click these buttons here. That takes the AC power, rectifies it to DC to charge the batteries. Once we've got power on the aircraft, we'll switch the nav lights on. If you switch the nav lights on from the standard cold and dark, you'll get some strobes as well. It's got these strobes up here that only work when the aircraft's on the ground with the nav lights. So I'll turn those off and just put the nav lights on in accordance with the normal practice to show this power on the aircraft. Keeping an eye on the current up here for the GPU, you notice there's nothing at all in the hydraulic systems, no pressure there. I need to turn this switch on here. That provides power to the gauges initially, and then we'll run the pumps. 3 hydraulic systems, 3 engine driven pumps, but only 2 electrical pumps. So pump for system 2, see the current it uses. Pressure's coming up. Pump for system 2, so sorry, that was system 3, system 2. We need to pressurize system 1 as well, so I'll open the cross feed between system 2 and system 1. And I also need to pressurize the brake accumulator. I'll do that with this button here. So watch the system 1 pressure as I click the button. That's basically transferring energy out of system 1, which is in turn coming from system 2. So the pump in system 2 is pressurizing here, transferring it to here, and that button sends it across. We need to keep the button clicked until the emergency brake pressure is right at the top. There we go. So switch off the electric pumps, switch off the cross between them, and coming up here we'll switch on the flight recorder and the clock as well. There we go, it's 6:15 local time. We'll try and get engine started by past. So ground power is providing the aircraft systems. The rest of the stuff we've got to do is on the overhead panel up here. We want to minimise the amount of power we're consuming, so I'll leave the gyro system off, I'll leave the autopilot system off, but we do need to set the aircraft up. So stuff that takes very little current, that's not sensitive to the power transfer, we'll turn those on. So vertical speed indicator, attitude indicator, angle of attack, turn, horizon. We probably need to put the flight instruments on, and on this side as well, the GPS and the other altimeter. There's the test on the AOA. TCAS system coming on. We'll have the nav radios on because we need to set those up. I'll put on one of the VHF channels, one of the VHF radios, voice recorder, and the other digital altimeter. We'll put the exit signs on and the fasten seatbelts. We could probably put the logo light on as well. That's not too much of a concern really. If you want to do it, it's in here. There we go. Okay, so we need to get the aircraft set up to fly over towards Sarajevo. We'll do the navigation stuff first of all, because we could do that with one pilot involved, and then once everybody's back together, the captains come back in from checking the outside of the aircraft, or the engineers finished checking the aircraft. We can all work through it. Let's get the navigation system set up. Turn it on. Self-test is done. We need to set the pressure. I always use 10-13 millibars. Scroll through to approve and acknowledge the fact that I haven't updated my nav database. Little message flashing here, it just tells me the system time's updated. Okay, so coming onto the flight plan page, it's got a flight plan already. Let's just clear that out. So I need to load the departure out of Sofia. I get that from the airport page. But it's currently looking at Sarajevo there, so I could push the cursor and then change the airport code to go to Sofia. However, the quick way to do it is to click message, click enter, and that shows me the nearest airport page. Looking for the departure routing, make sure we choose the right one. I'm looking for the OGOTA departure. OGOTA 4 Alpha, that's the one. Takes it to tchouzebra, then on to OGOTA. Load it in the flight plan. So that's not the whole departure routing. We'll have to fly the initial part of the routing on the radio aids, but that's no big deal. Let's put this side of the GPS here onto the distance track, page 3. So you change the menu, the pages you're looking at with the outer dial, and you change the sub-page with the inner dial. And these are the pages here that you scroll through. So the next waypoint I'm interested in, let's have a look at the flight plan. I'm not using a full route because in real life it's very unlikely that you'd ever fly the route exactly as you file it. And just to save time, all I'm doing is putting the waypoints in that are the boundaries between the national airspaces here. So OGOTA, that's still in Bulgarian airspace. Dolap is the next one I'm interested in. Dolap. That's the boundary between Bulgaria and Serbia, sorry. And the next waypoint is Mitno. Let's have a look. You can load these from an FMS plan as well, but I've never bothered with that, to be honest. The GPS can save flight plans, so if you fly the same route a few times, you can save them and then you don't have to do the entry all the time. From Mitno we go to NDB called India Lima. India Lima, that's overhead the field, on the field in Sarajevo. And that's what the arrival ILS is initially flown from. And then we'll put the airfield itself. So it's Lima, Quebec, Sierra Alpha. There you go, Sarajevo. And if you're loading it from something like RFinder or any of the other flight planning services, you can cross-check what you've entered in here with the distance and the tracks between waypoints to verify that what you've got on the GPS is what you expect to have. So with that done, flight plan 0, distance track 1, that's what I want. Before we finish up with the GPS, I need to make sure the aircraft is looking at the GPS and not the autonomous navigator. So I mentioned that the GPS isn't capable of flying that initial departure because of how it's coded, so we'll do that with the radio aids. So first thing is I'm going to fly a course of 091 from the Sofia VOR. Sofia's 112.6. I'm going to put that up here on the number 2 side. 112.6. Now the course, I could tune it in, we'll do that in a second for one of the other VORs, but in this case I'm only interested in the needle. That's the easiest way to do it. Where's my altimeter now? Come on, that should be on as well. Right, back down here. There we go. Okay, so using the VOR. So 112.6 for Sofia, outbound on course 091. I'll put that on the pointer here as well, the heading bug, 091. These gyros aren't aligned yet, so it's not a surprise they're pointing the wrong way. We're going to fly that out towards 5,000 feet, at which point we're going to make a left turn onto a heading of 333. I'll put that on the first officer's side, just to remember. And at that turn we're going to do a maximum of 230 knots. If you look at the airspeed indicator here, it's in kilometers per hour. I've actually cheated a little bit. I edited the background image for this airspeed indicator. That's a line for 250 knots, 220, 200, 180 and 160, just to make it slightly more familiar for me. So 230 knots, 220 would be fine. We'll do it at 400 kilometers an hour because we can do 400 kilometers an hour with the aircraft cleaned up. On that course of 333, we're going to intercept a radial outbound from Belovo 117.5. So I'll use this one here, conveniently, 117.5 is on here. We need to use the DME, so make sure I've got miles selected for both. Now in this case I'm going to use the course deviation indicator as well. It's radio 304. We can set it on here so that the aircraft indicates correctly. But this information is not fed back into the VOR radio, so we've got to make sure that that course selection is replicated down here to 304. That will drive the CDI pointer. If you wanted to, on the other one at 091, we're going to fly outbound from Sofia. And we could finish that off by selecting 091 on the first officer's side. See, the instrument's not powered up, but it is changing the bugged target in there. Okay, once we're captured outbound on that radio 304 here, we're going to fly to tchouzebra, which is one of the points on the GPS, so the GPS can pick it up from there. We're going to stop at an altitude of 8,000 feet today. Here's the standard altimeter in feet, here's the metric altitude, and the digital altimeter. When it's green, it's meters, when it's amber, it's feet. So put them both into amber. And I can set a reminder, an altitude alerter at 8,000 feet. There's no way for the aircraft to automatically capture that, but it will just provide an alert. So that's the aircraft setup for the instrument departure. See how we're getting on with the time. 7 minutes to go. Probably a reasonable point to start the APU. Make sure the fire protection system's on. Turn on the APU start. Set the motor start switch to start. Make sure you got all 3 lights coming on. Come down here, click the start button. Watch the current on the GPU as the APU is starting up. I love the fact that although modern aircraft have got all these systems automated, you can actually get really into the systems on this aircraft. They're not too different from what Western aircraft or modern aircraft have, but you've just got more control manually over it, so it actually helps you learn the systems. APU's available, so we'll click the APU on here. We've got frequency and voltage, and we've checked we've got current as well. The last thing I'll do is click this button here and hold it, and that opens the Apu Bleed Air Valve. You'll see the ready to start light goes off, and that's providing bleed air into the system. With that, we'll drop the external power. We'll come over here, dump the ground power, close the cargo door, close the passenger door, and take the ladders away as well. So we're in a position where we're almost ready to start the aircraft. Just some things to do with the pressurization first of all. So looking down here, 650, can I get rid of that armrest? No, there we go. So 650 millimeters of mercury, that's what we need initially. Pressurization is a little bit different than the schedule in Western aircraft. 650 and 0.6, that's all you need for the takeoff. So APU is supplying bleed air. We'll turn on the airflow regulators here and start to introduce some air. You see with that air the cabin's dropping in altitude. That's because it's pressurizing. And that's what we want. We want the cabin to be slightly pressurized compared to the outside environment, so that if you get any fumes from the engine start, that they're not being sucked into the cabin, they're being essentially blown out by the pressurization system. Set the duct temperatures and the cabin trim air to auto and set 21 degrees. And with that, we're in a position where the captain can be told that we're ready to start the aircraft. First officer's going to be doing the radio stuff, and over here the engineer will get the aircraft ready to start. So we'll open the fire valves to allow fuel to get to the engines. We'll turn on the fuel pumps. There's nothing in tank 4, so we'll leave that. Each of these tanks, obviously, each of these pumps has an electrical draw. Fuel equalizer, fuel automation system, fuel management to auto, flow meter and indicators. These are the fuel tank indicators here. These 4 here, and this is the fuel totalizer or the fuel flow meter. This is what's indicated in the system, so I can test it by increasing or decreasing the reading. And you see as I do that this needle here moves as well, and that's because this is also tank 1 there and total fuel system quantity here. So this is what's being measured, and this is what is being metered as it goes into the engines. So I said 12.75 was the maximum for the minimum for the aircraft, and that's what we've got, 12.75, 12.75. Verify that we've got the fire protection stuff on, and then put the engine instruments on. We're ready to start. So in line with common practice these days, we'll put the transponder to on, and we'll put the beacon on. Should have checked with the ground crew, make sure the ground crew are ready. They've in fact left the chocks in, so we'll tell them we're finished with the chocks and we're ready to start. Starting itself is really dead straightforward on this aircraft. We'll open the panel here, main to start, start again, just like you do with APU, select the engine and click the start button. Once the pressure comes up, click the start button. Light comes on and watch for the engine accelerate. When we get to 20%, we're going to advance the fuel cut-off lever here. I don't know why we've got fire valves and the fuel shut-off levers, but I guess modern aircraft have got something similar with the fuel cut-offs. While that's starting, I'll select generator number 1 with a view to checking the generator frequency and voltage before putting it on bus. Excellent, so number 1's nearly there. Once it gets to 60%, we'll flick the generator to check. Start it to number 2, start number 2, make sure it clicks into life. As it does, looking up here, checking through the phases, we've got 3 good phases, generator comes on bus. And ready for number 2 getting to 20%. As it does, introduce fuel. And we'll just repeat that process over again, start number 2 and number 3. The start process is really quite straightforward. And as I said, any of this stuff you see me doing here with these switches, if you're not interested in the system side of things, you don't need to do that. You do of course need to switch the generators on. There's 60% into the check position, Start number 3. Make sure number 3 turns. Checking number 2 now. Check the 3 phases. Click the generator on. As number 3 is accelerating towards 20%, advance the fuel lever. Now that we've got 2 generators on, I'm finished with the APU generator, so I'll turn that off. The APU is still running, still providing bleed air, it's just the generator's off now. Okay, so number 3, enter check position, good frequency, good voltage, 3 phases, generator on. Okay, now with that we'll deselect the start switches, close the door, and most importantly we'll start the elapsed timer. We need an 8-minute minimum warm-up for the engines. While that's running, we'll turn off the APU bleed air. I'll leave the APU running just for a minute or so for it to run idle, if you like. Finish the electrical panel selections. With all 3 generators on, we can close that cap there. Coming down here, we'll turn on the bleed supply from the engines now the APU bleed's finished with, and then we'll introduce some airflow. Watch the cabin vertical speed again. There you go. And as the air comes in, obviously the aircraft's opening its outflow valves to regulate the pressure. Up here now, we'll put the ice detection on, and we'll put the hydraulic servos on. Normally we do System 1, do a flight control check, System 2, flight control check, etc. But we'll work on the basis Felis and X-Plane have given us a fully serviceable aircraft. With that, I will stop the APU, so you see it start to spool down. I'll come through here towards the overhead panel, and we'll start powering some things up. I need the attitude gyros, the compass systems. I don't need the compass heat, I do need the magnetic correctors. Airspeed, short range navigation, radio alts, second VHF, gyros, HF, audio, DME, and we'll put the windshield heat to low and check the pitot heat will be available. With that, what I've got to do is align the gyros. That's where it gets a little bit more interesting. So what we'll do first of all is get the horizons lined up. You do that with opening the button here, clicking the button. Keep an eye on the little flag up here, and that's the gyros aligned. On the overhead, or the attitude indicators lined, click the test button and they're good to go. We need to do the navigation gyros as well. That's a little bit more complicated. Again, I'll do another video on why we're doing this at a later date, but importantly we'll just get it set up. I'll use this 2D panel because it's a little bit easier. We'll set the latitude for Sofia, it's 44 north. I'll set it to magnetic correction of the main gyro. Watch this needle here as well as the main gyro, or the main HSI here. The needle comes round to about 154, conveniently that's 156, that's where we're pointing. And I'll come over here, we'll do the same with the reference gyro. There's a little index around here, and watch the first officer's side as well. As the gyro rotates, you can see it just now, just that little index there. And once the main gyros are aligned, what we've got to do is get the magnetic correctors re-centralized. So there's the main gyros pointing the correct way, but the magnetic correctors, as you can see from the RMI, are completely wrong at the moment. That's because they store almost like a difference between magnetic and the gyro. So click it to DG mode and push the button until the RMI stops rotating. Quite far to go round. And on the first officer's side, that's all correct. We can check that that's done correctly by looking at the 2 HSIs, flicking them from gyro to magnetic mode, there's no movement, and on the right hand side the same thing. So the gyros are happily aligned. Should be able to flick the autopilot on now. And on the autopilot panel, we'll flick on the roll channel, the pitch channel, make sure we've got the indicators there for manual control, navigation mode and the needles. The other thing we need on here is the navigation system. This is the autonomous navigator. We're not using it, we're using the GPS, but to get the signals from the GPS into the system, this needs to be powered up. The other stuff we've got is the normal aircraft configuration. So we've got flaps and the trim. Looking at the load sheet again, it says we've got aft trim. So all I do is click this to the aft position there. That's the amber position. Bring up the takeoff card, you'll see it's 33.9%. If we look up here, you'll see we've got, where are we? 32. So it's aft of that, it's the amber position, which is perfect. And it was a flaps 28 departure. Last thing I do, it's not written in the book, but if you close the cap there, and oh, we've not got the boosters on, that's why that's not working. There we go. That gets the flight control information, or the flight control input into the system. So that cap closed, and takeoff not allowed light's gone off, and we know that the aircraft's set up correctly. So after the engine started, we run the little timer here. It's taken us, what, 5 minutes or so to get to the point where we're ready to taxi. We'll get our taxi clearance. Verify outside that we're all clear, making sure we're aware of wingtip clearance there, and verify that we've got 63% for the nose wheel steering. I'll release the parking brake, and we'll start taxiing off. Check the emergency brakes, watch the pressure here, make sure the aircraft stops again, and then back to 0. Once you've done it, the flight engineer, he would probably repressurize the system again. And off we go. I'll extend the lights ready for when we get further out there. So again, it reminds me very much of the Project Tupolev aircraft. That was a real challenge to taxi. All flight sim aircraft are quite a challenge, especially on a tight apron, because you just don't have that same situational awareness and depth perception as you do in the real world. So it's not a cheat at all using the outside just to help out, but shouldn't really need that at Sofia. At this point there's lots of other checks that the other crew members will be doing, but we'll leave those to run a straightaway so that we can allow the aircraft to taxi. Again, if it gets more challenging, quite a short taxi out, we just find somewhere sensible, stop the aircraft, set the parking brake, and then go through the procedure. You notice I've got the yokes hidden on the model here. That's because the eye point I've got selected is maybe not what you'd have in the real aircraft. You'd maybe sit a little bit higher up on the aircraft, but I find to work the systems it's more comfortable to be down here. So hiding the yokes, it's not really a cheat, it's just another allowance for the fact you're flying a simulated model on a monitor with a mouse and keyboard rather than a full cockpit around you. Okay, so let's do some of the things we need to do as we taxi out. Just verify the speed's sensible. Firstly, coming over to the engineers panel, the APU's shut down now, it's spun down, so we can turn that off, that'll close the door. And looking up here, we're pointing away from the terminal, so we'll turn on the Doppler system, that's another radar system for the corrections. We'll turn the transponder to TCAS, and we'll put the weather radar on. Push the button on the radar, give it a second or so for the ready light to come in. There you go, ready. Switch it to Meteo and then we're good. On the overhead panel, we've already got the windshield heat on. Stick the pitot heat on and verify that everything else looks correct. Quick check on the timer here. There you go. We've had 8 minutes, so when we get to runway we should be good to go. Bring up the takeoff card again. Just a quick reminder on the speeds there. So rotating at 220 kilometers an hour, roughly around there, and climbing out 245 up to 285 flaps 28. And we've got speed restriction around the corner, which we've decided we'll do at 400 kilometers per hour and clean. In line with the nature of operating a simulated model, as I said, I'll make more use of the autopilot than perhaps you would in real life. So, bring the autopilot page up there. I'm going to change seats for this turn. If you had a first officer sitting next to you, rather than having to swap seats, you could simply say, how does it look on your side? Are we clear on your side? But we'll cheat in the sim again. Very wide track on the main gear, so you've got to be careful, especially on tighter taxiways. Let's work on the basis we've been cleared to line up and wait on the runway. So lining up, make sure there's no traffic indicator on the TCAS, switch the lights from taxi to landing. No strobe lights on this aircraft to be aware of, apart from those little ground strobes which I've not been using. So make sure the aircraft's roughly on the centre line. Make sure the nose we're steering straight ahead. Come to a halt. Close the switch and make sure that the no takeoff light goes out. We're good to go. As soon as we get clearance from air traffic, we'll give the thrust levers to the flight engineer. So advance them roughly. We're looking for 94–95%. Make sure the valves close as we accelerate. 80%. I'll look out the front, release the brakes, and select takeoff thrust. It says in the book you can do a derated thrust of about 93%. I find that you very occasionally get the gear horn if you take off at 93%. So I'll use 95. Here's 220 kilometers, rotate. Positive climb, gears coming up, and pitch for around 15 or so to hold something between 245 and 285. I'll make life easy. I'll click the autopilot in. Verify the tracking on 091. That's looking okay. Passing through 1,000 feet. Speed mode. I'll reduce the power. We'll keep the aircraft climbing just now. Happy to start accelerating, so what I'll do is lower the nose. Had 15 degrees, so 10 to 15, I'll half that. As we start to accelerate, retract the lights. I'll put the aircraft into a heading bug steering just now as well. Again, verifying the tracking. 091 looks good. Keeping an eye, make sure it is actually accelerating. There's 330, so select flaps 15. And remember, we're turning at 5,000 feet. And there's 360 kilometers, flap 0. Flap 0 and the gear is up and off. 5,000 feet, I'm going to cheat, I'll put the auto thrust in there. And we'll turn the heading. There we go. I'm doing an auto thrust, that way I can use the pitch wheel to regulate the climb as well. Less than 1,500 feet per minute. Doesn't need to be like that, you can obviously just reduce power and that will, if you're in a vertical or a speed hold mode, reducing the power will reduce the vertical speed accordingly. But I do it this way on the basis I've got one less thing to worry about while I'm talking to you as well. I got rid of the takeoff card, so we're above 400 kilometers. Aircraft's clean. Lights are retracted and stabilizer goes back to neutral. So one of the things that's of interest is I can look at the VOR on the first officer's side, but I can't look at it on the captain's side because it's not showing me anything. I can fix that by clicking through VOR1 and then back to the heading straight away. Felis does say he's not 100% sure how that's supposed to work in reality, and I tend to agree that's maybe not how you would do it. But it works in the sim. Around the corner I can increase to 250 knots, so I'll use the auto thrust for that. Again, don't feel like using the auto thrust or the autopilot at levels the flight manual says you shouldn't be doing is cheating, because it's designed to be operated with multiple crew. So approaching 1,000 feet to go. There's the VOR coming in. Bring up the KLN unit as well so we can see that. And what I'll do is steer the aircraft onto the VOR radial with the heading pointer, with the bug. The reason I'm doing that is because it's not the smoothest of intercepts, so guiding the aircraft onto the centre line of the VOR, it'll hold it quite nicely once you're established. That being said, what I'm going to do is go up here. It's 1,000 to go, 500 feet to go. I'll click direct, Todro, enter. Reduce the climb rate a little bit. Auto thrust looking after the power setting. Not too much. Okay, direct Todro, enter. We've done that. Flick the navigation system into the GPS. A little bit of a wobble as it picks that up. You see, having an altitude capture would be pretty nice on this, but nevertheless. Let's try and capture 8,000 like we said we would. So it's now navving to Todro, and on that DT page it's about 2 minutes away. Todro is on the 352 radial from Sofia, so we can verify that we're on Todro by looking at the needle here. There's 8,000 feet, click hold. Quick check up here. Let's get rid of those and those. That's all fine. Probably have the exit lights off now. We'll leave the seat belts for a little bit. And quick check on here. Again, auto thrust in, but otherwise it's behaving itself. Pressurization makes sense, and the cabin altitude is climbing to 1,300 meters, which is what we expect. Okay, so let's work on the basis that from here we're speaking to the departure controller, we're cleared up to a higher level. I'm going to take the, I'm going to put it into speed hold, take the auto thrust out, and set 90% for climb. As we do, we're expecting the aircraft to turn. There's the waypoint flashing indicator there, and we'll go up to flight level 180. There you go, so we're just turning at Todro just now. And just verify, we said 352, 330, 340, 350, 352. And we expect to fly outbound on the 352 out towards OGOTA. Probably turn the auto thrust off again now. I only use it in the departure sequence simply to make life a little bit easier. Of course you don't have to at all. At 90% power climb rate, that's what, 2,000 feet per minute or so. Through flight level 100 we can accelerate. So I'll lower the nose. Again, looking at the pitch we've got at the moment, it's got about 8 degrees. I'll just half that. I'll come down to about 4 degrees. Let the aircraft accelerate. 5 meters per second, that's about 1,000 feet per minute. So for 1,500 feet per minute, have the needle pointing straight up. You see it's showing I've got 45 minutes at this rate to get to Sarajevo. So, blow the nose a little bit more, let it accelerate further. And again, this is one of the issues with having a scroll wheel support, is if you're panning around you can inadvertently click things, so just be careful with that. Let's work on the basis from now on. We're cleared up to flight level 360. That's going to be our cruising level today, so no further level offs. 550 kilometers, we'll click it back into speed hold, and that'll be us climbing away quite happily. Up here we'll turn off the seatbelt signs, leave the no smoking signs on, and that should be us ready to go. There we go, tracking out on the 352. GPS is doing the job. We're monitoring with this side here, and if we really wanted to we could use the 352 on here, just to be sure. 352. You can see the CDI bar is centered, but we also, if we wanted the aircraft to fly it, we'd have to point the bar the correct location as well. 352, nicely centered. Remember, use the first officer's side to look ahead if you like, or to cross-check, and use the captain's side to fly. So the only thing we've got to do in the climb now is monitor the Mach number. As the Mach number increases, as we get to about 0.78 or 0.75, click it back into Mach hold, otherwise we'll get an overspeed in the climb as it holds that kilometers per hour. Let's have a look on the outside. Go a bit further away so it's not quite as noisy. So there we go, that's a departure out of Sofia in the Felis Tu154. It's a fascinating aircraft to operate. This is part one, hopefully, of a video series. So coming up we'll look at the arrival into Sarajevo, and then a few videos on the systems on the aircraft to get a better understanding of the systems. And then moving on from there, whatever you want to see, by all means leave your requests in the comments section. If you haven't got the Tupolev but you fancy flying this kind of aircraft, Felis has also released his Yak 40 and Antonov 24. They're both available for free from xplane.org. And I think they can both use the KLM as well. I've got the Antonov installed, I've not done much with it, but I'll have a look at the Yak as well. Climbing out of Sofia, you can see the River Danube just to the north on the left hand side of the screen there, and this is just routing over the Balkans at the moment. It's a beautiful part of the world to fly over in real life, and it's really, it always gives me a nice warm feeling inside flying in this area, because quite a few years ago now, when I was in secondary school, this area was basically a war zone. It was unthinkable to me at the time that we'd be flying civilian aircraft over here, taking people on holiday, taking families on holiday again. And it's always nice that regardless of what happens in the world, normality returns at some point. It's a beautiful part of the world, and we can just see a little bit of that beauty in flight sims. So thanks very much for watching this video, and I hope you'll join me for the arrival into Sarajevo. Thanks very much.